Hello again. Now that we've looked at typical reading acquisition, we can consider what causes dyslexia. As we've seen, learning to read is a complex process that requires adaptations among multiple neural systems. A breakdown in the typical adaptations at any stage of reading acquisition can cause dyslexia. So there are probably many different causes of dyslexia. However, because learning to read changes the brain, it is often difficult to distinguish between cause and effect. Suppose dyslexics show some difference in brain activity from typical readers. Is this difference what caused the reading problem? Or did something else cause the reading problem, which prevented the typical neural changes and created the difference? For example, take phoneme awareness, which can be tested with a spoken task, such as the following. If you take the word phrase and remove the f sound, what is left? The correct answer is raise. Studies in English showed that dyslexics are typically quite bad at tasks like this, and the International Dyslexia Association has characterized dyslexia as primarily a phonological problem. And brain imaging studies found that activity in response to spoken language in this phonological area was reduced for dyslexics compared to skilled readers, which seemed to confirm that a phonological deficit causes dyslexia. However, a more recent brain imaging study was conducted with skilled readers versus people who were illiterate due to lack of schooling. Illiterates showed weaker activity than skilled readers in response to spoken sentences in this same area. This finding indicates that learning to read increases neural auditory response to spoken language. So dyslexics' reduced auditory activity may actually be a result of not having learned to read normally, rather than a cause. So now we know that learning to read restructures the phonological system, which affects neural response even to purely spoken language. We also know that phoneme awareness helps in sounding out words, but that sounding out words, in turn, helps to develop phoneme awareness. That is, phoneme tasks are initially performed via executive function and conscious knowledge. Once the sublexical pathway is established, it can support more automatic performance of phoneme tasks, yielding faster and more accurate responses. So let's take a look at the causal pathways. Good phoneme awareness at the pre-reading stage supports sounding out of words and allows good performance on phoneme tasks. Sounding out words, which is performed by fixating and focusing attention on each letter, leads to formation of the sublexical pathway, which eventually leads to fast, skilled reading. The sublexical pathway allows even better performance on phoneme tasks. In English, dyslexia is often associated with poor performance on phoneme tasks and inability to sound out words, which prevents formation of the sublexical pathway. This pattern indicates a breakdown here, which may be due to neural susceptibility combined with inadequate instruction on phoneme awareness. In consistent languages, dyslexia is instead associated with accurate sounding out of words and good but somewhat impaired performance on phoneme tasks, indicating good initial phoneme awareness. The primary deficit is slow and effortful reading. This pattern suggests a breakdown in the formation of the sublexical pathway, which is not due to an initial deficit in phoneme awareness. Rather, the deficit may be here. So a non-phonological skill, such as ability to allocate visual attention, may indirectly affect performance on phoneme tasks. Therefore, a mild deficit in phoneme awareness may be a result rather than a cause of dyslexia. So a phonological deficit cannot be the whole story of dyslexia. Rather, dyslexia is now best understood as a deficit in acquiring automatic associations between letters and phonemes, and between letters and whole words. Brain imaging studies have shown that many dyslexics use different brain areas for reading than typical readers. They recognize words using the right hemisphere and sound out words by activating the speech motor area. Other dyslexics develop the typical reading pathways in the left hemisphere, but these pathways never become as efficient as in skilled readers. Experiments have shown that dyslexics have various difficulties not directly related to reading. Some dyslexics cannot narrow visual attention or rapidly shift visual attention. We have already briefly discussed how a visual attention deficit could disrupt reading acquisition, and we'll examine this issue in more detail shortly. Some dyslexics have difficulty processing rapidly changing visual input, indicating poor timing of neural activity. Some dyslexics experience increased visual crowding. Crowding happens when objects are very close together and their neural representations interfere with each other, making it difficult to identify the objects. So here's an example of crowding. First, fixate the cross and identify the letter without moving your eyes. Pretty easy, right? Now fixate the cross and try to identify the middle letter. It is much harder, even though the distance from the cross to the middle letter is exactly the same as for the single letter. It is harder now because the middle letter is crowded by the surrounding letters. Next, we'll go through the different stages of reading acquisition and discuss ways in which each stage can break down. In the pre-reading phase, children learn to recognize letters. Some children with severe dyslexia have difficulty identifying letters. One reason may be use of the wrong visual pathway. Remember that the object recognition system has separate pathways for analyzing shapes and surfaces? If letters are mostly experienced as lines on paper or screen, the surface pathway may take over and analyze letters as squiggly patterns. However, letters should be recognized by the shape pathway, which provides the basis for the later formation of the sublexical and lexical reading pathways. In the pre-reading stage, children should learn about phonemes and the correspondence between letters and phonemes. Some children have more difficulty than others learning to consciously break speech down into phonemes. This may be due to poorer innate connectivity and coordination between the executive system and anterior and posterior phonological areas. In English, reading instruction may not emphasize phoneme awareness enough. The first stage of reading requires conscious knowledge of letter-phoneme associations, ability to blend phonemes, and ability to select individual letters in words. As discussed in the previous video, the simultaneous activation of the selected letter's parts and its corresponding phonological features may be important for the formation of posterior letter representations and the sublexical pathway. If attention cannot be narrowed to the fixated letter, parts of multiple letters will be active, which may hinder formation of the sublexical pathway. The second stage of reading requires the sublexical pathway and the ability to rapidly shift attention from one letter to another without moving the eyes. This allows much faster reading, which provides finer tuning of the sublexical pathway and development of the lexical pathway. If attention cannot be rapidly shifted from letter to letter, reading speed will remain very slow. This may interfere with the development of visual word forms, because neural learning depends on neurons firing together very closely in time. So if posterior letter representations are activated too slowly, neural learning may not combine them into a visual word form. If the sublexical and lexical pathways do not form during the early stages of reading, due to deficits in phoneme awareness or visual attention, skilled automatic reading will not become possible. Instead, right hemisphere compensation takes over, as observed in many dyslexics. Indeed, a brain imaging study of English-speaking children at these early stages showed that poorer reading ability was associated with weaker activity during reading in the visual attention system, in the posterior visual region that becomes tuned to letters, in the posterior phonological area, and in the visual region that becomes tuned to visual word forms. So this study indicates that weaker visual attention is associated with impaired formation of the sublexical and lexical pathways. We have looked at probable mechanisms for how visual attention contributes to the formation of these pathways, but researchers are still not sure of the details. The third stage of reading requires the sublexical and lexical pathways and very rapid letter processing, which likely depends on good neural timing. Skilled adult readers can process up to 10 letters within a fixation. However, if someone is more prone to crowding, they might max out at 4 or 5 letters per fixation. So poor neural timing and/or increased crowding may limit reading speed and/or accuracy in the later stages of reading acquisition. Such dyslexics would start to develop the typical reading pathways in the left hemisphere, but these pathways would not become as efficient as in skilled readers. So let's review the skills that are required and developed at each stage of reading acquisition. In the pre-reading stage, ability to analyze shapes leads to good letter recognition, and ability to consciously analyze speech sounds leads to phoneme awareness. Ability to learn associations, coupled with letter knowledge and phoneme awareness, leads to conscious knowledge of the relationships between letters and phonemes. Good verbal working memory capacity and phoneme awareness allow blending of phonemes into syllables. In the first stage of reading, where each letter of a word is fixated, ability to narrow attention to each letter, coupled with knowledge of letter-phoneme associations and ability to blend phonemes, leads to formation of the sublexical pathway. The sublexical pathway, in turn, increases ability to manipulate phonemes. In the second stage, where attention is moved across the letters, ability to rapidly shift attention, coupled with the sublexical pathway, leads to instantiation of the lexical pathway and to finer tuning of the sublexical pathway. In the third stage, where letters are processed without shifting attention, good neural timing and lack of crowding, coupled with the two reading pathways, allow more and more letters to be accurately processed within a fixation, which in turn reinforces the two pathways, allowing readers to become highly skilled and efficient. At each stage, breakdown of the required skills, due to poor instruction, inadequate practice, and/or less ability, will hinder progression to the next stage, yielding dyslexia. So to summarize, inability to recognize letter shapes or to develop phoneme awareness can disrupt reading acquisition right from the start. Later on, poor ability to narrow and/or shift visual attention may prevent formation of the typical reading pathways. Even later on, poor neural timing and/or increased crowding may hinder reading speed and accuracy. As reading acquisition proceeds, phoneme awareness initially plays a vital role, but its importance diminishes once the sublexical pathway is established. In the visual realm, different skills are required at different stages of reading acquisition. With sufficient instruction and practice, most children can develop good phoneme awareness, as observed in consistent languages. If dyslexia is present despite adequate phoneme awareness, the most likely cause is a visual deficit. This concludes our discussion of the causes of dyslexia.